Hello guys, I think we're live now. How's everyone doing? And let me set some things up. For example, we don't have music right now, so let me get a nice playlist that I've been listening to lately, which was actually sent to us by Robin, I guess. So let me get that link somewhere. Hello Robin, how is it going, dude? I was just about to actually look for our messages so I can open the Spotify link that I keep forgetting to save as one of my favorites. So I keep having to go back to to the Discord message every time. But I think we're good now, right? So let's do this. There you go. Now, I'm gonna turn it down a little bit and turn it up for you guys. And we're ready to start. How's everyone doing? Good evening, everyone. One more thing. There you go, my flashlight. Ooh, there you go. So my face is a little bit prettier now. Yeah, let's get started straight away, shall we? So I think in the last stream we were just getting started with the emulator, and we implemented support for a few instructions on the 6502 instruction set, and those were loading into the accumulator an immediate value, and also loading into the accumulator, storing the value from the accumulator to a memory address. Today I'm planning to add some more graphic support to the emulator in the same way as the Easy65K emulator had, which basically just takes the memory addresses from 0200 up to, I think it's 0400 or 0500, and then draws those values on the screen. And there's 15 colors, right? So each byte represents a particular color. So yeah, that's what we're gonna do today. Heavy Metal Mixer, hello dude. Hi, welcome to the stream. I think I've not seen your name here before, unless you've changed your YouTube handle. But yeah, welcome to the stream and welcome to some coding, dude. Yeah, let's get started straight away. So this is what we're gonna do. So if I just show you a little bit of a diagram before, so Excalibur, draw. This is kind of what the memory looks like, right? So you've got the 0 page memory here, which is like the first FF bytes. That's the 0 page, I believe, right? And then you've got like the rest of it, which is the actual possible addressable memory, right? Which goes from, I guess, 00 or 00FF. Is that correct? No, yeah, 00FF to FFFF, right? Basically, kind of this, which you can address with the word size for the 6502 processor, right? And somewhere in this memory, right? Somewhere in this memory, we're going to actually have our graphics, right? So let's say our graphics. Oh, this is a kind of shit. There you go, that's better. I don't know why it was different before, but this is going to be a graphics memory, right? And I would like to have exactly what this emulator has, which is 32 by 32 pixels. So in other words, we need 32 times 32 different bytes, which is 1024. So we need that many bytes, right? Let's convert that from the calculator here. And we're going to start that at memory address 0200, right? Robin, I have a question. When I use find package in the same CMake lists as the executable, I can find the files I need, but when I place the find package in another CMake file and include it with, it does not work. Right. Are you looking for packages in your system? So for example, are you looking for the lib for the SSL or the OpenSSL libraries in your system? Because that can change, yeah, and you have to provide what is called a hint, a hint to CMake to basically tell CMake where to start looking for files, right? Add to directory, it does not work. So let me know exactly how we're using this, and then I may be able to provide you with an answer. Let me be a hacker man again and remove this thing here. Hide element. Oh, that didn't work. There you go, that worked. So I don't know what 32 right is. So we want how many bytes? We want 1024 into decimal, which is 400 hexadecimal, so 0400. So we're gonna be starting from the memory address 0200, right? I guess. Yeah, good. So we're gonna be going to 0200 to 60600, right? So that's where we're gonna go from. And this is gonna be the range. So 0200 to 0, I guess 5FF, right? That's really the range here, because we don't include the 06. That would be in this memory here. But this is gonna be our little graphics, right? So what we're gonna do is we're gonna take each byte in here and translate it to a vector in our little screen. So let me see if I can add a little little thing here. And this is what we're gonna be drawing. We're gonna be drawing here. So this is the graphics. And we're obviously gonna render all of this with SDL2. Hello Slim. It's good to see you guys. I mean, seems to be quite a few people watching today, so hopefully it's gonna be a good stream. So I guess we can get started, right? Yeah, let's get started. Let me go into my project. I think it's called 65K CPP. I do want to kind of put a git init here. Oh, what's going on? Using master name, okay. Let me create another repository as well, because I'm going to actually track all of this. This song sucks, so I'm going to move it. I don't think you guys can see any sensible information by me sharing my GitHub screen. So 65K CPP. All right, or just CPP like this. Emulator 6502. Emulator in C++. Okay, and it's going to be public. We're not going to have any of this for now. We're not going to add a README either. And then we can do everything else that we need, right? So basically, it's going to follow these things. So we're going to, I guess we're going to commit everything. So actually, let's create a quick and easy gitignore file here. Don't forget to like the stream, guys. Yeah, don't forget to like the stream. Thank you, Robin. So Robin, when are you starting your streaming career, dude? Because you are pretty good at this as well. I've heard, right? I've seen the videos, man. They are pretty good. You should do a streaming thing as well. Not many people stream actual hardware, so that could be a niche you can fit, man. And I guess you get quite a few followers. I am streaming, but on Twitch. Oh, you are? Mate, let me know when you're streaming, and I'll come in and make up the numbers as well. Even affiliate. Yeah. Wait, so you are an affiliate? No way. What is your stream, man? I'm gonna check it out now. So I'm gonna guess it's like Force Robin. Yeah. Force Robin. No way, you've got like quite a few followers as well, like 80. That's pretty good, man. I mean, the problem is Twitch is so buggy for me. I don't know why, like, but I stream games. I see. I'll keep it here. When it loads eventually, we'll take a look again. I'll keep it there. Yeah, going back to this. Let's create that little gitignore file, right? So what are we going to be ignoring? Anything in .vs Code. We're going to be ignoring the build as well. We're going to be ignoring Conan. Yeah, we're going to be ignoring Conan. What else are we going to be ignoring? Test we're not going to ignore. And then everything.bin, I guess. Like that, I guess. And the CMake user presets. .json file. Maybe some coding stuff when I get a hardware component I'm waiting for. Yeah, I'm willing to watch that, dude. Like, I do enjoy people doing code, and more importantly, I do enjoy people doing hardware shit because I can't do it myself. But if you take a look at my subscriber list on what channels I'm subscribed to on YouTube, I would say that probably like 30% of them are like hardware or low level programming channels. Because it just, I don't know, I enjoy that. It's not very, what's the word? It's not very glamorous to stream or create videos on those things. But, you know, if you get the right niche of people, it's enjoyable anyway. Ben, yeah, that's the one. So Ben is the one, the guy who did the 6502 CPU from scratch, right? So I remember watching that video back in the day, well, when it came out a few years ago. I still lived in my old house, so this must have been like 5 years ago or something. And yeah, I nearly bought his kit until I realized it was very expensive to ship things from wherever he was in, is it Canada? I don't know, to the UK. So I ended up not getting it, but it was cool anyway. So we've got a geek no, and then we can add basically everything, you know. Yep, good. Let's do the first commit, and then let's do a git branch minus m main, and then we can do git remote add origin, and this has to be this. And yeah, I guess we can do now. So git push -u origin main. And there we go. We should have a Git repository here that we're going to be using for all of the code that we're looking at today. Why is Twitch not loading? There you go. Now it's loaded. Dude, that's cool. So you do like, I guess old school games and more. Oh, no, this is not old school. I'm going to subscribe, man. I'm going to subscribe here. Let me log in first and then you can... Oh, what is my login on Twitch? In fact, it's going to be on my phone. So you gained a subscriber, just saying. So I should get the notifications whenever you're streaming. Force Robin. Which one is it? There's quite a few of you apparently. There's a few Force Robins. Okay, you've got that picture. There you go, man. Subscribed. Thank you. Hello, Peter. How's it going? Hard platforming 2D games. Sounds cool. I bet you were a big fan of Flash games back in the day, like I was. I used to love those difficult Flash games. There are more Force Robins. Yeah, there are. There's like 3 others apparently. Peter, yes, sir. Yeah, I've already said hi, Peter. You know, always good to see you here. But welcome again, dude. We're doing a low-level stream here today. So I hope you enjoyed that as well, Peter. Okay, so we do have that GitHub repo now. I will probably post it here. If you guys are interested, you can see how things are implemented right now. We're going to be expanding on that. So the first thing we're going to do is obviously to add the SDL2, right? So we're going to be adding SDL2 to the build. So if we look at Conan Center and search for SDL2, we have SDL SDL2, that's the one we want. And all I want is this. What options are there? Okay, none. So let's look at the Conan file. And then let's add that brother in here. And of course, we're going to be generating everything again. So Conan, install all the debug stuff. As always, fingers crossed. Thank you. Yeah, whenever, I'm not sure if you're saying this about Conan, Peter, but whenever we do Conan, yeah, fingers crossed. I think that summarizes it fairly well. Like, fingers crossed. Is it going to actually work? Who knows? This is the average kind of Conan experience, isn't it? It seems to be working fine, actually. Oh no, it's building everything, all the dependencies. Oh no, there's an error already. Unsupported option. No input files. I mean, there was an error there. Is it actually going to matter? I don't know. There are so many errors. I'm seeing so many errors here. Like, surprising the thing as well, the build is still going. You know, the task I had at work for like the past 2 weeks has basically just been optimizing pipelines, build pipelines. So I've done so much reading on how the cargo ecosystem works and how it compiles stuff and how it caches things. It's insane. I know more than probably anyone you know about fucking cargo now. But point is, I've learned some very good techniques to actually make pipelines faster on GitHub Actions, especially when it comes to build caching, and it should work for C++ as well. They have like a cache on it. So I'll be interested in doing that on the stream in the future. But what I'm trying to say is, like, I'm really sick and tired of watching things build all day long. So that's what I'm trying to say here. Why is it building Ninja? Okay, Lib Ninja. That sounds amazing. Would love a stream of that. Yeah, I'm gonna set something up. I tried to do some stream on pipeline works before and that kind of stuff, but it really didn't get that many views. But if I maybe clickbaity a little bit, like make your pipelines 100 times faster with these tricks, then more people will watch it. Who knows? Or maybe just a long form video on that as well could help out. In fact, I need to actually, you know, that's a tip for you, Robin, since you like doing YouTube videos. Lives are good, like you get views. Like sometimes in my lives I get like 200 views in a few days, but that's it. Like after those 2 days, you're not getting many more views on that. What I really am lacking at the moment is like true long form videos. You know, videos that are like 10-15 minutes long, where YouTube can actually just recommend to people over like the space of a year. So I need to do more on that, and I have some pretty good ideas. The problem is those videos tend to require a lot of research and a lot of, well, development, and also my time to edit those videos and, you know, write scripts and stuff like that. So, you know, that's why I do more streams than videos. But, you know, hopefully hopefully long form videos will become a thing for me. Hello Al, you're new here. Welcome to the stream, man. Welcome to the stream, man. You know, hop on to learn some C++. We're just waiting for things to build, but it shouldn't be that long now. While the build is happening, we're just gonna just chat in here. So feel free to ask me any questions about anything, and I'm happy to answer or give some very bad advice. Yeah, I have a video on how to build an electromagnet like 4 years after I uploaded it. YouTube started recommending it and got like 80. Yeah, that's crazy. I've got some videos like that as well. Like some crazy. I remember having this like gradient descent video that did absolutely crap when I released it. I think I got something like 200 views in a few weeks. But then like a year later, it just got like a few thousand views, I think. So yeah, it's just random how the YouTube algorithm works. Random. So in fact, I don't even know what video is the most viewed on my channel. If I had to guess, it would probably be my Conan one, because that one is actually pretty good. And without bragging, I'll probably do it better than most of the other videos out there on Conan in terms of explaining. Because I actually I do remember watching some of those videos and then thinking, yeah, I can do better than that. So yeah, only for, I know, C++ modules, of course, that blew up. Actually, that did really bad when I released it. It did maybe like, I think it was like 100 views in a month. But then when the news that C++ 20 modules were supported by CMake came out, or when that became a thing, then this gathered so many views, it's ridiculous. How much do you know about OpenGL? Not very much, dude. I mean, I've worked with OpenGL before, but I'm not a very well-versed OpenGL engineer. But I can probably answer some graphics questions. I mean, it depends on how hard the questions are. But yeah, I know about the rendering model. I know how to do textures and that kind of stuff, but anything more complicated, I'm probably not your man. Robin, you sent me a link and I can't really see it. I think it's a private repository. You have to make it public, I think, or you invite me to it. Plus, let me know. Do you want me to review that on stream? Because I'm not. If it's a private repository, let me know if you don't want me to open it. Like, how is this doing? Oh, there you go. So get text error, build fail. Conan exception. That's amazing. What is the actual error though? There you go. Error. Incompatible function pointer types initializing void with expression of type void. Any website with projects for newbies to C++ and programming in general. Websites. I mean, I don't know, man. I mean, you can probably just do like leak code and stuff. That should probably teach you a little bit of it. But the interesting thing is actually doing a full-on project in something. Like maybe you create a very simple like bouncy ball. If you wanna like program, if you wanna learn how to do graphics and use something like Open SDL2 or something like that, and those projects tend to actually teach you a lot more. I'm gonna make it public. It's about the CMake stuff I said earlier. Code of Advent. Yeah, Code Advent is pretty good. So yeah, we got the first error here. So let's see. Which one is it? Gettext. So luckily we're not going to have to build everything else because hopefully Conan has already cached the remaining of the stuff. But yeah. It's public now. When you have a build going to yeah, I will do. So while it's building, we can review your code. So why is gettext not working now? This is so annoying. So OBS stack, incompatible function pointer types, initializing void star attribute no return with expression of type that. I mean, this is a warning that's enabled by default, and I guess this project, there's nothing we can do apart from disabling that warning, which is kind of annoying. Why 6502 instead of the 8085 or the 6510? I don't know, actually. I mean, I wanted the 65K family just because it has a very simple instruction set, as opposed to looking at the 68K, which is a little bit more convoluted. And you know, long story short, it's a processor that's fairly well known, right? I mean, the NES used a version of it, and because the instruction set is quite small, it's actually very easy to write an emulator for it because you don't have to support that many instructions. But to get there, we first need to to compile this shit here. OBS stack lib text style. There you go, backport a new lib patch to fix building on Clang 16. So this is a Clang issue, I guess. Error incompatible function pointer initializing void, that's what I have. So someone has already got a patch for that. 1 year ago though. What the hell? So why is this not working for me already? Is that the actual error I'm getting? Yeah, that's exactly the function that I'm getting. So it's basically something that just fails on Clang, right? I mean, I could kind of just use GCC to build the dependencies and then just link them in with Clang later. That should work as well, because it's supposed to be binary compatible. But the problem is, why is this not working? So Conan gettext I kind of want to check on the Conan forum as well, so the Conan GitHub, Conan Center, index GitHub, to make sure there's no issues with SDL here. We're gonna raise a bug here because this is a recipe bug. I guess we're just having, or they just haven't added the correct version of SDL2 or the gettext dependency that has that patch in it. But first of all, no, I don't want to do a new issue. There you go, that's the one. So someone's already got this issue. Last week I was compiling project on the 15, and the Clang 15. Between now and then, they went to Clang 16. It seems that, okay. And I bet the logs are the same exact ones that I have. No, this is a different one, in fact. Oh yeah, there you go. This is that one. And yeah, they found exactly what we had as well. So basically backport this through a patch in gettext recipe. I have implemented this patch, but it doesn't seem to be fixing the build issues. I am not sure if I'm just misunderstanding the build testing process. Hello, Antonio Jr. Yeah, guys, it seems like it's just broken for Clang 17. So yeah, it seems like it's just broken for Clang 17. Let's try and apply this patch manually. Shall we do that? Let's hack Conan. So if we look into, well, if you build it again, it shouldn't build everything again, right? Because we have everything in the cache already. So it's just going to be trying to compile gettext again. By the way, for those who just joined, we're trying to build SDL2 on WSL with Conan on Clang 17, which is a pretty new version of Clang. But there is a bug in it because Clang has one of the warnings enabled by default. The gettext, which is a dependency of SDL2, has in it. Like they go against the warning basically. And let's see if we can find that warning again. So it's just doing a bunch of checks here. These checks are so long, it's crazy. In the meantime, let's try and like apply this patch. So if we go to Conan, I believe it's in P packages, right? And if we look at gettext, is it in data? Nope. Is it in export? Nope. If we do a tree here, what do we get? Okay, so it's gonna be wherever this is. Okay, so this is in GNU lib local, libtext style, which is, where is it? It's in source, of course. Why did I not see S in source? S. And then we have a patch here. And this is like live debugging for Conan recipes for you guys. Yeah, so if you look into one of these patches, right, this just has the patch needed to build something here. So you can see it's just a git patch. Okay. So what we need to do is like basically just copy this. So clang fix patch. I think .patch or something. Clang fix .patch. I'm gonna put it here. Oh, where is it? I'm gonna save that, and then we're gonna try and see where those patches are applied in the recipe, right? So for example, if I just look for this particular string from the Conan gettext package, and by the way, you should have failed now. You can see here the same error as before. If we do a find name, or in fact, just a grep minus an r, we want to look into the files, right? So you can see that Conan data, you know, it has a patch file here. And we also have another export. So let's open these two files and see what we can do here. Because maybe we just have to apply them there. Ooh, vim. So what we need to do is we need to firstly get the SHA for them, right? Conan 2, and then we've got, what is it? P, gettext. We've got S here, and we've got patches, SHA-256. So I'm just going to confirm that it is actually this patch. So for example, 066CD. No, this is not the right one. I don't know where this is coming from then, to be honest. What kind of... I thought this was a 256 SHA sum, right? I don't know. But anyway, in Conan data.yaml, what do we have there? Is that an MD5 one? Yeah, let's try MD5. What's the command for MD5? It is. Oh, okay, right. Yeah, is it because of the size? I guess you could tell straight away, right? So echo MD5 sum, right? So let's open that again. Conan manifest, and then if we have one of these here, and we put our Conan patch, what is it? Clang fix patch. And if we do an MD5 sum, okay, of clang fix, is that? But if we do the 0041, yeah, 8AC2. Yeah, that's the one. Thank you. Well, looks like it in my eyes, yeah. Thank you, Robin. As usual, dude. If it wasn't for you, I'd be like lost here. But yeah, I'm wondering, we do need this, right? So I'm just gonna put that in there and see what happens. I don't really know the build very well of Conan and how he deals with this stuff. I believe this is just to make sure that the files are still, you know, still have the right SHA or the right MD5 sum, so it hasn't been tampered with. But let's add it here anyway. Ooh, there is something here too though. I don't know what this means. This might be something that incorporates all of these. I don't know. Let's see. So we're going to save that, and we're also going to go into E. I think it was Conan data. Is it? Yeah, sources and then patches. Let's see if that's going to automatically apply the patches. First of all, did we even get anything to say that, you know, we're running the patches and whatever? Applying the patches, packaging, building, generating folder, calling build, right? Applying patch, there you go. So we have applying the 002. Now let's see if we name it something a little bit better in this case. Patch description. Fixing the build for Clang 16 plus. Right? Let's try and run the build again and see if it works. Oh no. So I've got not Clang. What is it called? Conan. I am interested in figuring out There you go. So we have applied the patch. With a bit of luck, this is going to work. I don't know. In the meantime, we said we're going to review some of the code from Robin. That's right, Robin. What am I looking at here? So you've got a CMake lists, you've got test source, a native application that will do some cool stuff. Nice description. Let's look at this. So version 3.5. Ooh, that's a very, very low minimum version, dude. CMake standard 23, required standard, visibility presets hidden. Okay, so target name is the project name. So the project is TwinFob, you've got a target called TwinFob. And then you set up the environment, you build tests. So no, using the add subdirectory module does not work. Add subdirectory modules. Ah, okay, so what are we looking at here? So you've got that. So you find the package slint. So find package slint. This is gonna look for slint.find module, right? So where is your modules here? So as soon as you do this, Robin, right? As soon as you do this thing here, this is gonna look for a file. Let's open it here. So when you do something like this, so find package, slint required, right? This is actually looking for, is the SOAP SDR that's broken. All right, so you do have that in your modules path somewhere. Yeah, I'm just gonna say, anyway, I'm gonna finish my explanation. So this is gonna look for slint or find slint.cmake or whatever it is, right? In the CMake paths, right? Usually it will look for the CMake modules path first or something like that. So basically when you call CMake, you can pass in, CMake and then -d CMake modules path. And then this is like the directory where the find files are, right? This is how I would do this. So if you've written your own find file, you got to make sure that you tell CMake where to find it. So SOAP SDR doesn't work, all right? Fetch content declare. Okay, SOAP SDR. Yeah, so same thing here. So in here, as soon as you do a find package SOAP SDR, it's going to look for that find SOAP SDR.find file, right? Which you have to write yourself, by the way. So I can't see it in here though, so maybe that's what you're missing. You're just missing the find file for this. And there are examples where you find file example in CMake. I would probably just recommend reading this. I remember reading this article here. It's one of the few documentation pages on CMake that are actually pretty good, because it has, or used to have some examples, not anymore apparently. Let's see. There is one particular page that has a find file example where you can just kind of basically copy and paste. It's not this one either. But if I place the find package in the same file as I created in the executable, as I create the executable, it works. Yeah, I don't know the default behavior for CMake. Maybe it's finding it somewhere. But it's what I said, dude. Like usually when you have your own defined modules, you have to pass this in here. So CMake modules path. This will tell CMake, look, my find files are here, and use these find files, so that when you call slint required, it expects this file to be in here. Good evening, sirs. Hello, Day of Redemption. How is it going, dude? So we still have incompatible pointer type. So we still have that issue. Oh, this is kind of a bummer. Let's try and actually just apply the patch manually now. I'm getting tired of this now. Static attribute no return. Can you have multiple CMake module path? Good question. I don't know. Let's take a look at the documentation. Maybe it's like a comma separated list. There you go, semicolon separated list. So you can have multiple ones in there. So you can have, you know, day 1 and then something like day 2. So yeah, you can have multiple. So Day of the Redemption. Welcome. Are you by any chance the person who pushed stuff to Urchin? Because, you know, I've had 2 PRs recently on Urchin, and I guess they're from the viewers of this channel, but I don't really know. Because you guys have different names for your YouTube handle, so it's difficult for me to figure out. But let me know if you are. Yeah, so going back to the file itself, we're just gonna have to manually apply the patch. Gettext tools, and then we have, which file was it again? Source libget libtext style. That's the one. Wait, which one was my patch anyway? So which one was it? Clang fix.patch. So this is in a different directory. This is a different file altogether. Yeah, this is a different file altogether. That's why. Yeah, so I basically have to look at wherever this happens. So wherever this happens, I need to find it within the source file. Not really, I haven't had time to push something to my fork of Urchin. As mentioned a couple of days ago, I'll create a PR probably by... Yeah, no worries, man. I remember that you mentioned that you had a PR, and I've gotten randomly just 2 PRs like in the past day, so I was wondering if one of them was you. I was going to say thanks for pushing, but yeah, thank you for taking the time anyway. So we're going to do a grep -r for this particular text here and see wherever it happens. So that doesn't happen anywhere. That doesn't happen anywhere. However, we do need another one, which is in here. So source lib line 351. Line 351, that's what we need. This is the problem here. Can we decipher what this is? So incompatible function pointer types, initializing void pointer no return with an expression of type void star. So which one is the void star and which one is the other one? A few line above was the static thing you search for. Yeah, so this is like a macro, right? I guess that's like being replaced in here. And whatever, and it just does this. It just does exactly. Wait, where's the patch again? So vim. So this is what the patch does. It just no return attribute, no return. Yeah, but I can't see that being returned. That, oh yeah, there you go. Static attribute no return void. And out of interest, what does this do? Well, we know what this does, right? This says exactly what it does. It just expands to this. So a void, it's a function pointer that returns a void star and takes in a void. And it has the attribute no return. This song is not doing my head a good thing right now. I was wondering if you have a to-do list by any chance. If not, then I'll probably just try and figure out how to write unit and integration test and go. So Day of Redemption, actually I do, and it's called the GitHub issues. So if you click on the issues tab, there's a bunch of like things that I keep putting in there that I know we should improve, and one of them is a test issue. So yeah, I mean, take a look at that. I do have a few PRs as well regarding adding new tests and stuff, so it should be fairly easy for you to find that out, but I can go over that in the next Urchin stream as well if you're interested. So yeah, that expands to this. Incompatible function pointer types, initializing that with so print and abort is a void. Okay, so basically this function here should really be, if I'm not mistaken, this should be another patch. Right? Yeah, print and abort, that should be this. That should be this. Attribute no return, void. Function that takes in. Yeah, I'm just gonna manually do this here, right? Can I just do this? Attribute no return. I think the static has to be at the very start. There you go. Attribute no return. And then we've got a void. Okay, yeah, that should do now. Let's see. So I'm not sure if the patch is gonna actually be able to work here, because we've basically just changed things manually. Yeah, I mean, that's what we had, right? That's what we had anyway. So no return and no return there. And that basically has to match whatever we had. No, we cannot have this song. This is a copyright song. There you go. Yeah, I wasn't expecting this stream to be 90% fixing Conan again. Kind of annoying, but... Conan is beautiful when he works, and a pain when it doesn't work. I mean, the same with VC package, right? The same with anything to do with C++. By the way, what are you guys up to today? What are you guys coding? Come on. It is indeed beautiful when it works. Yeah, and hell when it doesn't work. Mostly done maths today. Nice. Are you revising for an exam or something? Also, Robin, tell us the maths you're learning, dude, because you're at university, right? So you must be learning some hecked up maths. Trying to learn C++ macros. Trying to learn C++ macros then. Come on, they're the easiest macros to learn. It's just if you think of it as a copy and paste, that's what it is, man. That is what it is. It's just a copy and paste. Right, so how are we gonna get an error? We'll figure out. Multivariate calculus, nice. Unknown attribute no return. Right, so at least we get something a bit different now. Attribute no return, static, attribute no return. Okay. So attribute no return. Which line was it again? 329. 329, which is this one here. Don't understand how this doesn't work. Well, attribute no return is not a thing, but have I made a typo? Attribute, yeah, I have made a typo, haven't I? Oh gosh. Multivariate calculus, optimizing functions and triple integrals. integrals, yeah, nice. I remember doing those as well, man. Did you learn about the Jacobian and stuff? I remember having to work out the Jacobian of things so you can then take on multivariate integration. And then there's all the stuff about changing variables and stuff, which it was nightmare. It was very, very, very interesting, but nightmare anyway. I'll tell you what, Robin, once you finish it, dude, like, do you know how many times you're going to use that stuff in your life? And this is coming from someone who used to love maths. I used to really admire people who are good at it, and I still do, obviously. I still think people who are good at maths are amazing. But I tried to learn everything myself, and I studied it very hard. And I've used it exactly 0 times after uni, I'm not going to lie. Finalizing my ISAQB advanced exam paper. I have to hand it in by next Tuesday. Afterwards, I'll get my promotion to software architect. That's pretty good, man. I don't know what that is, so I guess that's something to do with software architecture, but I'm happy for you, Day of Redemption, and keep on going, dude. Seems to be doing well. Don't say I'm so sad that it is not applied more in the real world. I mean, it depends on what you work with. You know, if you work for like some company doing maths, very hardcore maths, like finance companies actually do quite a lot of maths, believe it or not. You know, when they're doing models and stuff. So maybe if you get into one of those jobs, then yeah, you'll be working on it. Graphics as well. That's, you know, very interesting. If you like linear algebra, graphics is a good place to go. And I think, did it work now? Is it gonna fail again? Yeah, graphics is a good place to go if you actually do like linear algebra. But aside from that, man, you know, it's difficult. It is, if you know maths, it makes you a better programmer. You stand out, that's a perk. Yeah, 100%, I agree with that. If you know maths, you just have the mindset. Yeah, let's turn this into a short, shall we? So if you know maths, and if you do very, very deep mathematics, and I'm talking linear algebra, I'm talking, you know, integrals, graph theory is a pretty good one, and it's in the field of programming as well. Graph theory is extremely important. You just get into the mindset of solving problems, and you just get into the mindset of thinking about solutions in a certain way. So it does massively help you come up with like efficient programs. It helps you understand the programs as well. So yeah, I mean, I'm not saying don't learn maths, because it's obviously interesting and it's obviously useful. But I will say you don't need to do maths to learn coding. It's, you know, they are correlated, but they're not necessary. And we fixed the build, by the way. That was it. ISAQB stands for International Software Architect Quality Board. It's a certificate that is mainly for prestige and to provide customers some kind of validation that they can trust you. Yeah, sounds good. Yeah. You know, I've been meaning to do some sort of certificates for a while now. So like I've consumed all of the AWS like simple courses. I think the Cloud Practitioner is the one I actually watched all the way through and studied. But I don't have an exam or any certificate to say that, you know, I'm a certified practitioner of these things. But I think they are important though, especially if you're going for high responsibility jobs like software architect, right? You need to understand how things work in general. So those certifications are very, very useful. Very, very useful indeed. I will say some of them get quite expensive as well, especially the more advanced AWS ones. They can go for like thousands of pounds, dude. It's crazy. Hopefully I'm going to take my ham radio certificate soon. Nice. So it's been an hour, and all we've been able to do is just to fix the Conan build. Incredible. Incredible. Yeah, maybe we can push this patch. I think I'm going to push this patch to Conan, maybe later on today after the stream. Because, well, that guy didn't seem to have it done, and we've actually figured out the exact change that we need to make to actually make it work, right? So yeah. Hopefully I'm going to take my... Okay. The one I'm doing is 3.6k euros. Oh my god, dude, that's ridiculous. However, I mean, I would trust you a little bit more if you had that, to be honest. Like if I'm hiring you to, you know, architect my whole system for a large company or something, I would probably look for those certificates as well, man. So it's an investment in yourself, isn't it? It's indeed an investment in yourself. There you go. We just had another PR. I'm not sure if like I'm being targeted. I'm preparing a PR with additional documentation and easier to set up. Starting the development process. We'll create it by the end of it. Oh yeah, that's you, I guess, right? Day of redemption, dude. I wish I knew your first name because it's a lot easier to say than your YouTube handle. I'm gonna call you I do. Yeah, thankfully my employer is paying for me, and I'll have to pay with my soul later on. Yeah, indeed, yeah. I would love to take the ISO IQ certificates, but they are so expensive. I don't even know what they are, man. Now just watch the Conan build fail elsewhere, somewhere else that we're gonna have to fix as well. And I'm just gonna like shut down the stream. I'm just gonna like say fuck it. It's not worth it. All of this to build SDL2. Is it really worth it? Where are we on now anyway? So, oh, it's security related, yeah. Nice. I thought about getting into security, you know. I thought very hard about getting into security. It's not that difficult once you have quite a lot of experience with low-level languages and stuff. But yeah, I mean, there's quite a few certifications you need to pursue. You know, saying that, I've worked with people who claim to be security engineers. Oh, no. You know, people who claim to be security engineers who knew the very basics, and I guess it's a good field to get into anyway. What's the purpose behind SDL? Graphics and sound, I think. So what failed here? Error in building method. Error, compiler does not support GNU. Oh, why does it need to support? Why does it need to support that? Pulseaudio. We're gonna fix another one here. Yeah, I mean, GNU 11. That's the GCC 11, I think, standard, which has some GNU extensions. It's kind of annoying because we're building with Clang, right? So what can we do here? Are there options for this? So you can say without pulseaudio, for example. So run, configure, source configure. Okay, maybe we can just hack this, right? Maybe we can just hack this again. I'm losing the will now. Which build was this again? This was for... I don't even know. Let's do it again. It was for pulseaudio, I think. Right? Yeah, for pulseaudio. So let's take a look at that. CD pulseaudio. And we've got a source. And let's do a tree level. Oh, tree level 3. Where is the configure? It's in source, right? CD SRC. SRC. Configure. Okay, so checking where the compiler does that. I mean, we could just be very cheeky and just comment this out, I guess, right? So as echo, what even is this? This is a configure script written in some sort of language that is not Bash? Or is it Bash? I'm just gonna try and remove this for now. Okay, C flags. Let me kind of do so GNU 11 equivalent for Clang. This is another patch that we have to do here. I'm following and learning. I'm currently using a Mac with Clang. I don't understand why this is not. Oh gosh. Wait, did I mess up the formatting here? No, I think it's fine, right? Yeah. FI. Okay, so we do have an if. Oh, 1 second. The stuff you're currently doing is something that prevents me from ever going deeper into C++ rabbit hole. Yeah. I mean, this is just a Conan rabbit hole. It's not really a C++ rabbit hole. I'm just fixing things by applying little patches. Believe it or not, this is just the building side of things. Like, it's not usually this difficult. Al is fine. Okay. Alright, Al. So, So there's FI here. I definitely want to remove this though from here. And then I'm going to remove this as well. And are we Gucci now? I think we are, right? Okay, so what we have here. Is this a generated file by any chance? It can't be, right? It can't be a generated file. Oh, it is a generated file. There you go. Never mind. Let's go back into configure and remove everything that we've just added. Because it's a generated file and there's an easier way to remove these flags, I guess. And then we've got this here. So check compiler flags here. And we're not going to do this flag. I do want to see which one the equivalent GNU 11 is. Well, it doesn't matter anyway, because our compiler is going to be running, it's going to be compiling everything with C++ 17. So okay, that didn't work. Why? Compiler does not support GNU 17. Is it because it's already cached somewhere? So if I remove my configure, what happens? What happens if I remove configure? Configure not found. Okay, I cannot remove the configure file. Great. Can I bootstrap it though? Build information, generating. What is this anyway? What kind of build system is this? Configure.exe. I've seen this before. Cool. Oh, it's AlterConf, that's right. We want to generate that configure again. You create 2 files and make file in. You'll be writing the files, AlterConf, configure, massive configure script without. Like, what is the actual command though to generate the file? Is it just AlterConf here? There you go, we've got configure again. And now I should be able to just not see that GNU 17 again. GNU 11. There you go, it's coming to the owl. Ugh, that was interesting. So has that actually cleared the cache in here though? That's what I wonder. Because this seems to be picking up the AlterConf from last time. There you go, now he's doing it again. So is whether or not we're going to run into issues with Clang not supporting flags again. Dude, this is over an hour and we still haven't fixed the entire build, but we're getting there. So have you guys had any issues with Clang before like this? I guess you, Robin, probably have, right? Did you go into a rabbit hole like we are? Oh no, it's now that we're doing the check-in, so let's see. Gotta love it, yeah. So Clang 17 options need to detect all undeclared function not needed. Why are you using SDL2? Why not something like Raylib? I don't know what Raylib is, to be honest. And SDL2 is fairly lightweight and compiles on many different machines. Raylib. Is it C++ or C library? Examples. Well, is it just like a... Yeah, it's a C library, nice. It's a C library that can be used easily with C++, yeah. I could use it, but SDL2 is also kind of like pretty standard for doing this stuff. In fact, no dependencies, yeah. I was gonna say maybe this has a dependency on Raylib. Unique OpenGL abstraction layer, usable as standalone module. This is cool though, this is really cool. Thank you, Al, I didn't know about this one. I'm definitely gonna star it as one of my favorite ones. So is it new? When is it? When was it created? So 2014, there's still even before that, I guess, right? Yeah, I didn't know about this one. I didn't know this library at all. Not really new, it's already at 5.0, yeah. That sounds really cool though, I like it. So it's like an entire game engine written in C. And it supports quite a few different platforms. That is cool. Now this is usually where it fails. Yeah, we're gonna switch to Raylib, I guess. If this doesn't work, we're definitely gonna switch to Raylib. Let's see, is it on Conan? It should be, right? Seems like a fairly standard. Yeah, Raylib is here. Has an easier API than SDL2. Cool. Yeah, I mean, I always use SDL when I kind of need a lightweight engine, just for my own like 2D stuff. In fact, fact, I've not done any SDL2 in years now, but I have used it before. So init window. Okay, yeah, I mean this is really cool. I'm really down to try this, actually. I'm really down to try this. And finally, we're building SDL2. Jesus, that was a journey. That was a journey. I'm gonna add Raylib 5 as well to the build to see how long it takes to build, because there are no dependencies on it, so it should be quite good. All libraries are bundled into Ray. Ah, okay, no, never mind. They do have libraries like GLFW, so this one is based on GLFW, right? It's an intermediate API, so kind of like OpenGL State Machine API, yeah. So it uses GLAD here, GLFW. Right, so it's not dependency-less, it still has a few dependencies. But it seems to be way more lightweight than SDL, right? And yeah, we've got it. Now for the sake of it, let's add Raylib and see how long it takes to build, shall we? And while it's building, we can chat a little bit more. Right. GLFW. Oh yeah, we're gonna have an issue with GLFW. I'm pretty certain, or maybe not. So that's the first dependency that we need from Raylib. Use an external GLFW. That was so much like better. Yeah. Change of plans. We're gonna use Raylib. I'm actually quite interested now. Right, let's get the examples out. So let's create a window, right? We're gonna try and like code really fast now because we're running out of time soon. Right, Emulator app. So in here, we need to include Raylib, right? So what do we have here? Did we include Raylib at all? Does it say what the package is? Raylib. Find Raylib. Did I reconfigure it? Okay, anyway, so we're gonna include Raylib up here in the app. Maybe down here actually. So links to Raylib, but there is a typo in here. So what is the issue? So if we go into Conan and do we have find Raylib anywhere? Find that. Or Raylib conf. Hello AlgoVoid. Welcome to the stream, man. So what we want to do is like figure out which targets I should link against for the Raylib stuff. Where is it? Alcov. So I guess it'll be down here somewhere, right? Raylib.conf. So Raylib targets, debug targets. Raylib targets.cmake. What do we have? Conan target declared Raylib. Okay, it's just Raylib, right? Okay, which means now we can go into the app and start writing some Raylib code. Oh, main.app, okay. Yeah, let's just copy and paste all this code into here, shall we? Why do we have so many windows up? Right. So I have Raylib.h. Okay, seems to be working with IntelliSense. And this is like an infinite window, I guess, right? Let's build it. Let's see if building has no issues. We run the emulator app itself, and we should expect to see a little window, right? There you go. Congrats to your first window. I like it. I really like it. Oh, yeah. So how are we going to do this? So basically what I want to do is maybe I can create a thread that will be drawing on the window all the time. And the emulation can happen on a separate thread, right? Let's try that. So let's look at the documentation for async C++. Example. Right, please give me a nice example for async C++. So algorithm future, vector, okay, async, has to be async. And that comes from the future header, I think, right? So async launched the third. There is a difference between the third and whatever. Specifies a launch policy for a task. Okay, defer. The task is executed on the calling thread the first time its result is requested. The task is executed on a different thread, potentially by creating and launching it first, right? So what we want to do is, like, we just want to do an async here. And we're going to pass in XX. What is X? Okay, yeah, we can do that. So let's use async here instead of threads. So future. We want to basically want to be able to like create a function here called bool. I don't know. Draw graphics or something, or just draw, right? Which is, I guess, just gonna do this. Just draws forever. And we obviously need to put a mutex, or we need to put a reference here to the CPU. And of course the memory kind of needs to have a mutex somewhere, right? So we can protect the memory. Oof. This is gonna be interesting. But yeah, let's just put the CPU here and not worry about the race conditions issues. Mutex to protect. And then we can kind of double buffer things later on. But yeah, let's put that there. The window we're going to create is actually a 32 by 32. So this is going to be the 6502 graphics. And let's say we draw, I don't know, on every, I don't know, is it sleep or something? Okay. It has to be this thread, right? I want to sleep for a certain number of frames, basically. So I want to do like something like 10 frames a second at the start. Wait, sleep is a thing. Anyway, so seconds. Unsign in seconds. So it comes from, okay, no, we don't want that. Why is my IntelliSense not working properly? Come on, guys. So no Conan. None of that. This thread sleep 4. That's the one I'm looking for. It's in thread. It's just not giving me. Let's add chrono up here as well. What's the issue here though? Must be a class, okay. STD. Like. Why is the IntelliSense not working? It's just milli, right? I love having IntelliSense not working. STD, milliseconds, duration. Yeah, it's just milliseconds, I think. Let's say we sleep for whatever. Like, we have 1000 divided by 30, right? That's the number of milliseconds we want to sleep for. This should build still. Or maybe not. No member name milliseconds in chrono. Are you sure about that? STD chrono milliseconds, microseconds milliseconds. Oh, milliseconds. Milli, yeah, thank you, yeah. Realize that. Okay, so that kind of works a little bit better. So now this should at least, I'll make sure we only draw almost 30 times per second. So right, clear background to, let's clear array black. Ray white. I'm gonna say that it's ray black here as well, right? I'm not entirely sure. And then we can draw the text. No, I don't want to draw text. What I want to do now is for each of the this is the thing here. So we're gonna go from memory address 0200 to 05FF, right? And each of these memory addresses will contain a byte, and each byte represents a color out of 16 possible colors. Oh my god, namespace. So let's do that. Stud array, which is going to be, I guess, not a tuple, but what can we do here? So we need the RGB, right? So we kind of need a struct here for the RGB. So we have red, which is going to be std uint at, and then we're going to do the same thing for blue RGB, green and blue. So we will have an array of RGBs here, and they will have 16 colors, right, overall. So we can do 16A. Yeah, so let's do that. Okay, so that should be... Oh. That should be what we need now. So So this is the color table that we have. Why is 0 not a thing here? Too many initializers. Oh. Did I do one too many things here? This is just entirely sense being stupid. So Ray Black is not a thing, by the way. Oh, it's just black, right. There is no Ray Black. Ray White is just a special definition there. Yeah, thank you, dude. So I should probably read the chat a little bit more. But anyway, so we have that and excess elements in the initializers. I think if I do this, it should work now, right? Non-function ends in a void, yeah. So return true here, and window should close. Okay. That's cool. So every color is red for now, right? So all our 16 colors are red. But what we're gonna do is we're gonna basically work out. Yeah, so this becomes very easy. In fact, I did yes with Docker. You did yes with Docker. What do you mean by that? You gotta explain. You gotta expand it. That is a complicated sentence. So for the CPU, right? So for each, I guess, int I, and then we have 0x0200 to I less than 0x60600 plus I. So why is this not working? Okay. Is this Zelda? Because we can't have Zelda songs here. It is. Zelda just gives us a copyright strike straight away, unfortunately. So yeah, for each of these memory addresses, right? So we're gonna get something like, you know, we're gonna do CPU dot. Is it memory? Yeah, CPU dot memory at the address I. This is going to be a value between 0 and 16, but it has to wrap around because we only have 16 colors. So what we're going to do here is we're just going to do mod 16, I guess. That will make sure to wrap it around, right? So that's a color. So auto const color ID, right? This is what we have here. And that color ID is going to be coming from here. So we do have a const, auto const color itself, which is the array color table. I realized I spelled color without the U here, and every Brit will know that this is the right way you spell color. F the Americans. Color table, color ID here. And with that color ID, we want to draw this color rectangle where it should be, right? So perhaps we don't actually create a 32 by 32 window. We could create something a little bit better. So 256, 512, right? 512 by 512. That should be divisible by 32. And if we look into here just to make sure, so 512 divided by 32. So each pixel will have 19 by 19, like pixels actually. So yeah, color, not color. Color, ooh, color, yeah, that's right. I don't know why the IntelliSense isn't like giving me good things. Yeah, Like, it's just giving me loads of loads of errors everywhere. It's because of the modules. As soon as we work with modules on C++, it's kind of a hit or miss. So static const export there. Yeah, what do we have here now? So we want to make sure that we can find that position, right? So we want to make sure to find, I guess it draws the rectangles by begin drawing, clear color black, draw text. What draw do we have here? So we'll draw rectangle. Yeah, draw a rectangle is a thing. What does he actually take though? An integer. It takes an integer. Draw billboard, capsule, circle, circles, cube, ellipses, mesh, pixel, point 3D, rectangle lines, rectangle, pro, rounded. We just want the simplest rectangle. Like rectangle filled, is that a thing? Rectangle lines. You know, the C++ IntelliSense is terrible. Come on. Like, what even is this? Like, dude, why did it not find draw rectangle? Yeah, the C++ IntelliSense LSP is in a very bad state. It's been like shit for maybe 2 months now that I've realized that it's kind of very bad. I don't know why. But anyway, so we've got position XY. I guess that's the left, top left, right? Draw color field and width, height, color. What is color? Color is RGBA, right? So this should be fairly easy for us to do. In fact, we can actually convert all of these to... It seems like we can just do color in here, right? And then kind of just put an extra 0 everywhere from the looks of it. Then there's no conversion needed anywhere in our code. Having to do this 16 times though. I wish I knew Vim well enough. I don't know Vim well enough. Could have just copied and pasted as well, I guess, but 0 is wrong. You need 1 for 8. Oh yes. Oh, don't tell me that. Don't tell me that. Yeah, maybe we'll use the power of Vim now. So we're gonna replace all the 255s dot 0 0 with 0 with simply I guess 255.0.0.1. And there you go. Vim did help us in that case. And Vim IntelliSense is nice, by the way. Control V for visual block mode, go down and press 1R. Oh yeah, shit, that's the recording mode and then it just replays, right? Whatever you did. Control V for visual mode, block mode, go down. I'll try that next time. I was using the sed like command. Yeah, draw a rectangle. Press Control V. Control V does something else. I don't even understand it. So if I go into visual mode, right? Visual mode, like that, and Control V. Visual block. I mean, I'm not sure if it works like this, but it does something weird. Yeah, this is weird. Does it select multiple lines? I guess it does, right? Oh, copyright song, copyright song. No Legend of Zelda songs, guys, unfortunately. So we have that, yeah. I don't know what the hell happened here, but let's say we draw a 0 0. I guess we can calculate the row, right? So we can do auto const row which is going to be, right, this is where this is how many times I can be divided by 32 in integers. And autoconst column is simply going to be the remainder of this, right? So now we can do x and y. So x is going to be row, I is going to be col here. This is going to be, I think it was 19 by 19, right? So 19 by 19 in this case, and then the color, which is the color itself. Make sure we have that. Okay, that's good. So now I'm expecting to see the entire screen as red, like when we run this. So let's run this again. No, I mean, it's not quite what we get, but I don't know what happened there. So it, all right. Yeah, I don't know what happened there. Let's do it again, shall we? Why is it still running? Why is it still running? Because you never call draw. I never call draw. Like this? I don't know what you mean, dude. I thought this drawed rectangle already does the job. Okay, yeah, maybe I should actually look at the documentation, to be honest. No, your own function draw. Oh yeah, of course. I mean, yeah, that's a good point. That's a very good point, dude. Thank you. Yeah, let's call that. So we wanted to create this asynchronously, right? So we want to remove this whole stuff here. I want to do something like std async. And what did we have there? List without Zelda. Oh, thank you, Robin. Thank you. It's not just Zelda though. There's a few other songs as well that remove the draw call. Yeah, I'll remove that. That's a good point. I am just looking at the async example again because I want to call async and not a thread straight away. std C++ async. I used to know these things off the top of my head when I was doing C++ every day, but unfortunately by not doing C++ every day, you kind of lose the knowledge a little bit, if I'm honest. So this is the one. Async, and then we take a function reference x foo int iron string. Can I just call it function itself and not an object? Calls x foo hello with the fall. Yeah, I mean, we're gonna use this anyway. Just let me know and I'll remove the copyrighted songs. Oh, I guess that's your stream, right? That's your stream playlist. That's cool. I didn't know that. I thought it was just from a random person stream. But now that I read the name on the playlist itself, I realized I was being an idiot the whole time. Yeah, I'm not sure. Did you have this problem with Twitch as well? Like, because on YouTube, if you play a copyrighted stream, it will let you play on the stream. But then an hour later, it's gonna like remove all the monetization from your video and say, you know, this is monetized, you can't do it. So the only option it gives you is to like mute the entire thing. Now you don't have the problem. Interesting. Maybe YouTube is a little bit more painful. So we want to run the draw element here, and we want to pass in the CPU. So basically, I want to put this up here somewhere. I want to see if this is gonna, first of all, compile. No, it doesn't. Use of undeclared identifier CPU. Oh yeah, easy 65k. Wait, what? You don't do C++ every day? Tell me you've been rustified. Yeah, unfortunately not anymore. Yeah, I mean, my job now requires me to do Rust most of the day, and very occasionally C++, but no matching function for async. Does async not support function pointers? So std async. That is a weird design, isn't it? I think I knew this. I kind of knew this deep inside, but blocked it from my head. Correct use of async. Can you do a functor? So in other words, can I do a lambda? Because a lambda kind of boils down to a functor, isn't it? So if I do something like emulator CPU, and then if we return that, I think that should work, right? Or maybe not. Maybe not too. Maybe we need an actual renderer function class or something like that, right? Very annoying, but so we've got absolute class, implementation class. Out of interest for you guys in the chat, what is the language that you write the most? Because for me right now it's Rust. I'm not the best at Rust. I still think I'm better at C++, but I know Al does, is it Golang Gal? And so do you, Slim, right? And Robin, I've no idea what you do though on a day-to-day basis. I'm gonna guess something like C, because you do a lot of machine work, but so what do we have here? So async func is right. I am perhaps not doing this right. Let's try that again. Do I have to pass the pointer? No. No matching function for a call. No candidate function is not available. Not known conversion from bool to launch for first argument. Ah, yes, it's because I'm skipping the launch thing. Is it? Yeah, there you go. That is why. I'm just being an idiot. But still, this will not work, I think. No matching function for async. Substitution failure. Candidate ignored with function no type named type in. So it takes you. What the hell? Let's try the thing again. So we have emulator CPU here, CPU there, and return draw CPU there. No, this still doesn't work. What am I doing wrong here? What am I actually doing wrong? You can definitely use async with lambdas. Yeah, that's what I thought too. That's how I've learned it in Bjarne Strausstrup book. But why is it not working now? So let's try it again. Let me try and decipher the error though, because it must be something I'm missing here. No matching function for call async. No, candidate template ignored. Substitution failed with function equals lambda. No type named type. No type named type. Maybe because you provide a pointer to the CPU and expect a reference to the CPU. Yeah, I mean, in that case there is std_ref or something, right? A reference to a CPU. I mean, foo here requires a reference to a string. So what are they doing down here? What's x? Yeah, I'm pretty sure I have to call std_ref or something. Oh, yeah, std_ref async C++. Ooh. std_ref, that's the one, yeah. I forgot about this gem up here. So std_ref. Ooh. Let's try that. Yeah, better. Yeah, for those who don't know, so Stefan actually raised a good point there. You can call async with lambdas in C++. However, async doesn't pass down references very well, because the idea of it is like you shouldn't really be passing references to your async functions, because it's supposed to be a little bit safer than that. But there is a type you can call stud reference that will wrap. It's like a thin wrapper on your object, and if you pass it to async, deep down inside the call, when it actually comes to calling the draw function here, it will just cascade, it will just sort of like unwrap itself as a reference. So maybe because you provide a pointer to the CPU, expect a ref to CPU. Yeah, it's just what you get with working with C++, I guess. What we can do now is at the end of it, can we do, I guess, hello Yassine, welcome to the stream. By the way, welcome Stefan and Yassine. Good to see you guys. We can do a1.wait. Wait, how do we await for for a future now? Because this is a future type, right? If I'm not mistaken, this is a future type. Yeah. So let's see how we can await for it. a2.wait. It's just a2.wait, I guess. a1.wait. I said that because I've used raw lambda before in async, so something was probably wrong with your type. Yeah, usually that's the issue anyway with C++ async. But figuring out what exactly is wrong from the C++ error is sometimes a pain. So you just have to trial and error sometimes. Okay, so we definitely have something bad here. What do we have? So a main in draw. Shadow bytes around the boogie address. Ooh. Ah, yeah, see? This is, we have memory safety enabled here. So it detected a race condition, right? It detected a race condition somewhere. Address sanitizer stack, buffer overflow on address this. Ooh, that is interesting. Okay, the memory only has FF. So it should have been FF. Let's build it again. Yeah, I mean the number of bytes that 6502 has in the memory is FF. So that was a bug. That was legit a bug. Now, do we get, there you go. So this is what we get now. Everything is being drawn in here, which is weird. That is a pixel. And that is interesting that this particular value is red and none of the others are. I mean, this should all be 0, right? If I put a breakpoint here, so we have color ID, it's always going to be 0, always. In fact, if I put that there, yeah, it's always going to be 0. So when this is 0, what is it doing? So raw, that means that this is always 0. 16 and 4. Ah, oh yes, yeah, of course. There you go. We have to time these things by the size itself of the pixel. And also draw rectangle is not really drawing me a solid rectangle. It's doing something weird. I mean, this is where I need you, Al. What's the actual function to draw a square? A rectangle, like an actual rectangle. So, okay. And now we get nothing here, which is cool. I mean, not cool, but so draw a rectangle. Draw color filled rectangles, vector versions. Yeah, let's take a look at the documentation, shall we? What are we looking for again? We're on... Oh, drawing a rectangle does draw the rectangle. Interesting. Raylib, yeah. Now you're drawing something, yeah. It's not drawing something because you are outside your visible scope. Now it's not drawing something, I don't understand what that means, but I guess I'll find out. I mean, we don't want the cheat sheet, we want the actual documentation. Rectangle shades red, so it draws that one over 2. Ah, yes, you're quite right. I guess you may have a point there. Is it? Wait, 32. But it shouldn't be outside the screen though. Because if we have 512 and each pixel should be 19, right? Let's take a look here. If we divide it by 32. And this makes sure that the row and the column are always within. Oh yeah, no, you're quite right. This should have been 9. But let me think about this. So 19. I am confused now. Is the maths wrong here then? I thought it was right. So what I'm doing here is like I've got a 512 by 512 screen. Each pixel, because I want 32 by 32 pixels in the end, I divide that by 32, which is 19. So each pixel should have 19 by 19 pixels wide. Now the first row and the first column here. Oh yeah, no, this is incorrect. This is actually incorrect. And the reason being is because, yeah, this should have been relative I or something. So that would have been, so relative position should be I minus 0x 0 2 0 0. And thank you for pointing that out. It was actually incorrect. One call should be your X and Y of your grid, yeah. It should be, yeah, but it was, well, if you have 512 pixels, shouldn't you have 16 as your size? Good question. I think I put it through the calculator and it gave me, why did it give me 19? Yeah, no, it gives me 19, right? Okay, yeah, now we're good. Now we're talking. Now it's still not drawing things, but So this is gonna go between 512. Wait, am I doing the maths? Oh, dude, yeah, you're completely right. I'm doing maths in hex for some reason. Jesus, yeah. There you go. That makes more sense now. And yeah, you're quite right. So all the 19s will have to be 16s now. I don't know why I thought 19 was right, because obviously it's a power of 2, so the result should be something like an even number at the very least. Okay. Now let me figure why this wasn't... This relative position is always 0. So I is between that and I plus plus, right? Let's just step through this and see what happens. So the first one, relative position is 0. That should be 0 and that should be 0. Fine. That should be 0 and that should be 1. That's also fine. Yeah, we don't have anything here. (16 by 16). And that is width and height, right? Out of interest, it's not the other point or something. Let's look at the cheat sheet again, which is just the documentation. Yeah, width and height. And we have the right color there. What is the color value? So the color value is just red with an alpha of 1. And if I'm not mistaken, that's what we need, right? Unsigned character, yeah. So these values should all be good. Yeah. Out of interest, what if I just draw? We clear the background and we draw everything here and we end the drawing. And every time we encounter 1, we draw. So what if I do a draw rectangle here? That's from 0 to, I don't know, 512. It's X and Y as well, right? Am I tripping or something? It's not Y and X. So this is position X and the position Y. Okay. Well, there is a mistake already, so position X should have been column, I guess. And this should have been row right here. So X and Y, width and color, right? So if we just do color, just white now. Ah, yeah, that's why. It's because that should have been 1. I'm not sure if someone already said that. It's not a float value, so let's use Vim again to change here. So that should probably give us a nicer value now. And he explains the first time he drew a non I guess rectangle or non-straight rectangle is because all the rectangles were being drawn by 1 pixel difference every time, and it was also like basically completely see-through. So the very middle was actually red. So, and now this should hopefully work, right? This should hopefully work. Let's remove that one. Okay, so what is the issue here? So There you go, completely red now, which is good, right? Which is really cool, really cool. And this is just reading the pixels every. There is a race condition, by the way, in this program. We're reading the memory. We might be writing to the memory as well as we read, but we're going to leave that as it is. So all the pixels are kind of red, as you can probably see. And what we're going to do now is, like, we're going to, I guess we're going to support one of the programs that we had here. And I think the actual program that I want to support is this one. Let's see here. So if we do hex dump LDA install, so we support LDA already. So the emulator has to support the pixel drawing program, which has all of these instructions, right? The ones we already support are these ones here, LDA and A5, right? I believe those are the two that we actually support in the app itself. So if you guys look at the emulator, there is a switch case somewhere that supports A9 and A5. And what we don't support yet is A2. And I got to figure out which instruction that is. I think A2 is actually, so where is it? Ooh. Yeah, is this one here, right? This is what my program was in the end. So we have LDA supporting, we support LDA, and we support this one here. Now we've got to support, oh, this is going to be difficult. Maybe we're not going to be able to do it in the stream, but we can try. LDX, so loading to X. Loading to X is basically the same as LDA, right? And I believe it is FF there. I believe it's A2. So A2 is the one we want to go for. So it's, again, very similar to X, very similar to X. We're just going to copy and paste this and probably put in alphabetical order, or in A2 here. And this is immediate. Is it an immediate mode? Is it an immediate mode thing? I don't know now. Let's look at the... Yeah, so this is an immediate mode. And with an immediate mode instruction in assembly, it basically means that you take this value, literal, as a literal, and store it into X. Now, if it didn't have this here, this would mean take the value that's in memory, FF, and store it to X. But in this case, this is what we have to do here. So let's go for it. So we have A2 here, and we're going to keep this in check. I'm going to suggest a little refactor here. So instead of having the load into accumulator up here, yeah, so this is what we had for A2, load LDA immediate. So we're just going to copy and paste here. So this is going to be LDX, immediate mode, and we have the value there. And you know, you can probably guess that everything that changes is the value itself. So which variable you kind of want. Can we do better than this? I think we can. We can kind of take in, I guess, an emulator. Then remember to change the available colors unless you want the search for a bug that might be. We'll change the color soon, dude. Definitely. We're gonna take the emulator CPU, and can I do a member? How do you do a member to a pointer variable? So how do you do pointer to a member variable? I know that this is sometimes useful in C++, and this is what we're going to do now. Pointer to member variable C++. Why didn't you make a disassembler? It would make stuff easier down the line since you'd interpret the instructions anyway. Good point. I mean, for me, it's just easier. I just want to do the emulator for now. There are plenty of disassemblers online, and I was using one of them, by the way, already. This is where I got this code from, so I kind of know what the instructions are. But we're starting small, dude. We're starting small and then we're gonna go big. Don't worry about it. Have you got any cool projects to use as reference? Let me know if you know any interesting disassemblers out there in C++. I'm happy to look at how they do things. So P speed, access via pointer member. Okay, this is a good answer. This is the simplest example I can think of that conveys the rare cases where this feature is pertinent. I'm gonna change that because it's... Oh, okay, so we just do... like this, right? So we pass in the thing and then... like bowl and fruit. Class bowl. By the way, this guy's really good. He used to be in the standard of C++, I think. He gave some talks and stuff. You can find him on YouTube. CPP. He's got some talks on very interesting like signed integers and fixed point arithmetic. And he's a really good guy to work with, by the way. He's a really good guy to work with because I actually worked with him for 2 years at Jaguar Land Rover. So it's interesting that I get to kind of like come across his profile every now and then on the internet. It's a very, very good answer, by the way. But yeah, look him up. You guys might be interested if you like floating point arithmetic and low level stuff. He's got really good talks on that. John McFarlane. I wanted to write more of my paper, but somehow I'm debugging and coding with my by all means, I'll feel free to go and write your paper, dude. You don't have to stay here, man. That's what I'm saying. But yeah, we need CPU and then we need a pointer to register. Or in fact, what do we need to do? We need a register, emulator, registers, and then a pointer to reg, right? And then what I want to do is like, the problem is I'm enjoying it too much, right? And a 30 pages is by definition no fun. Yeah, but it's a definition, but by all means you kind of have to do that, right? I guess. I'm glad that you're having fun, dude. It makes me happy. I mean, all I'm doing is just like coding some very bad C++ here. So what do we need? We need CPU .reg, and then what do we need to do with the fruit that we get here? Bool iterator count. I just get straight into reading opcodes and interpreting those as I go. Related opcodes are usually close to each other. Yes, they are. They indeed are. I mean, I'll have to pull up the instruction set in a bit, but 60502 has only like, less than, I think it's less than 30 instructions overall, right? So, or less than 40 or something like that. For a functional iterator. Pointer to an iterator. Right, I'm still trying to use it. So reg. Does that work? How is reg undefined? It's here. I have a concrete type, and I kind of just want to pass in like this. This is the kind of register you're gonna have to increment in coming this image, right? Because of Zelda, yeah. Dude, there's only like Zelda songs. There's So expected a type specifier. I think this is how you do this, by the way. Does this work? No, it doesn't. Wait, this song is kind of popular as well, so I'm gonna expected a type identifier. A type specified is required for all declarations. What? Int bowl of fruit. Which is an integer. Wow, this is confusing. So I have to actually pass in a type identifier here, which in essence is stud uint8 t, right? Ah, okay, and the type itself is that. That makes more sense, I guess. Does that work now? No, not quite. Member reference type registers is not a pointer. Did you mean to use dot? Did you mean to use dot? No, I didn't. I guess what I meant to do is maybe dot this. That won't work either, right? Because it has to be a pointer type. What if I did this though? I'm just hacking the language now to make sure, to make it work with what I want it to work. Oh my god, how is this so difficult? I just want to pass in, I want to say this is the variable you're going to increment for this function, because I can then generalize LDX, LDA, and LDY into the same function because they all do the same thing. That's essentially the motivation for all of this. So a.bx, right? Let's try that. So a, you're saying this dot this, it should work. But I tried that before and it didn't work, so this doesn't work. Because the register is inside, you know, this is the register, and it has the registers that I want. And this points to the variable that we want. Remove the first reg. No, I can't remove the first register. This is the actual, like pointer to the variable that I want here. And the first reg is, it's just the same name, sorry, but the first reg is a variable inside CPU, so it has to be there. Pointed to a member variable. It looks like it blocked my URL links, but a masswork.at. Okay, thank you. Yeah, that's Stefan. That's the one I'm using as well. So Masswork is a really good website for 6502. I was reading the instruction set on that one before, and it's also got a very good disassembler and emulator now, which I've been using to create this program that basically just draws a different color to every single pixel. So that's what I'm trying to basically support with my emulator now. I'm not sure if that makes sense, but yeah. I recall seeing at some point a huge table of 6502 opcodes, which was really colorful and good. Yeah, they have that too, yeah. So declare a pointer to a member data. Yeah, so object is that dot the pointer. So I don't understand why this is. Okay, that worked. It's just this doesn't work for some reason. Which is interesting because the star has a precedence over whatever. Over dots anyway, so it was, I thought it was doing the same thing. But anyway, so now what we can do is like we can do LD immediate here, right? And if I'm not mistaken, if we look at the instruction set for 6502, which Masswork has one, as Stefan was just saying to us. If we look at LDA up here, which has the immediate mode, these are the flags it sets, N and Z, right? And if we look at LDX, he also sets the same flags, and LDY sets the same flags. So we can do all of these instructions here, and they all take the same sort of like operator for the immediate mode, and they have the same cycles and bytes, right? So what we can do is we can just call the same function here, right? And set the flags in the same way. And now we no longer have this anymore. So what we need to do is like call in LD immediate, and then in here we're going to pass in the emulator or register, or what is this? Emulator register, and then we're going to pass in the, which one is this? This is LDX, right? So this is X here, and this is what we're going to be setting. And this is actually LDX in immediate mode. And the same thing for this one here. LD immediate, and then we have emulator, registers, and then we have A here. And you can probably guess, you know, implementing the other LD one, which is LDY, is the same thing here. Matt, try the following. CPU register. Oh yeah, I just tried that, sorry. We reached at the same point. The parenthesis forces it to the reference and you get an integer. Ah, okay, so that's why it was failing. Thank you, dude. You are correct, yeah. So now, I think it was the one at Masswork, but I found one the Ultimate C64 reference to be great as well as. Okay, cool. You know, all of these functions can actually just be, I guess, I mean, we can just kind of put all of these into here, to be honest. I mean, it's the same thing for all the functions, right? So this is the first bit of refactoring. And instead of void, we're going to return the bytes read. And the bytes read is simply going to be a stud size t. Right? Instead of LD immediate, so that's what we're going to do here. And in this case, we're going to just return that. I am wondering here, so what happens if I do? I want to be able to kind of fail if I return a null opt here. So let's put a stud optional. Oh, stud size t. Right. And then we have the program.size. Ooh, I guess we also need the program here, right? Yeah, we can do the program. Int uint the value. So instead of that, what we're going to do is just take a stud span of program. Okay. And we don't need that anymore. And then we have the value here. And then the value there. And the value here. Hello, Carlos. It's good to see you, man. And then we return an actual offset that we read. And now all this code here basically just boils down to a call to that function, right? So this is the function that we want. Instead of value, we want the program here, right? And the same thing for the other one. We of course want to check that if this didn't return me a nice value. Oh, what was it? What was I doing before? Bytes read equals 2. Yeah, so we need to do bytes read. So yeah, so we need to check that this returns something nice. So auto. And if we do work's been crazy. How's it going? I see the community's going. Yeah, man, the community's going. I mean, we've had more people today, so I'm enjoying having more people watching me. But I'm glad, dude, that your work's been crazy. That means it's busy, right? And that means you're earning that dollar, right? Stefan, why did you do CPU register instead of CPU reg? Because CPU reg is a reference to a variable. And CPU reg is not a pointer. If it was a pointer, I'd have to do that, yeah. If it was like an iterator or a pointer. But that's why. That's the reason. So yeah, I mean, I need to check if red, if not red. Oh, too much rust. I've been writing too much rust, guys. We're gonna return here. What do we have here? So return std no locked. And then I guess at the very end we have gotcha, thanks. I'm off now. Wish you all a good night and see you guys. Happy coding with Matt. thank you all. Yeah, dude, thank you for joining again and have a nice evening. And don't forget to write that paper, man. Get that certification out. And yeah, man, I'll see you next time. Bye bye. I don't usually do late streams like this one, but I'm actually quite enjoying this, so I'm gonna keep going for another half an hour or so. And I hope you guys appreciate that. So. Yeah, so what we want to do is like do a bytes read here equals. What does bytes read actually do? What does it actually do? Return bytes read. I can just set it to null opt here, and then instead of having to do all of these shenanigans, I can just set the bytes read to that, right? And then kind of do this. And then the same thing here. So not really, it's actually been very difficult, so I had to put extra hours to learn and get better. Oh, really, Carlos? I thought that mean it's good, dude, but yeah, I'm sorry, man. But I'm sure that, you know, if you keep putting these extra hours and if you keep applying yourself, you will eventually, like, be very good at it, man. I should be doing my thesis too. I have a compiler to do, but it's 1 AM here. And I don't feel like opening my laptop. Sub to you, by the way. Thank you, Stefan. Thank you, man. I look forward to having some suggestions by you in the future about compilers, because you seem to be also into the same thing, so. Bytes read, yeah. So I can do bytes read up there, and I can do the same thing here. So bytes read is equals to that, and this should return me a optional of size t. Good. And then I can break as well. Ooh, I can break as well here. And I have to break here too. Otherwise it's gonna run the other instructions. Ooh, there's a massive typo here. What have we got wrong here? CPU program. So no variable overloaded. Plus, what is bytes read supposed to be? Size t, auto. Okay, yeah. So this is actually supposed to be stud optional. Stud size t. Deduction. That's kind of messed. Yeah, and by the way, we actually get this for free as well, because now we have the same function that implements LDX, LDY, and LDX, LDY, and LDA. So let's look at LDY here. So this is what it is, and what's the opcode? It's A0, right? So A0 is the one that we want. So A0 is the one, right? Opcode is A0, yeah. This one loads into Y, and we actually just need Y there. And that's it. We've implemented all the immediate mode load into the accumulator, and so on and so forth. But now, you know, we've got this one handled, we've got this one handled, and we've got this one handled as well. What's A9? Let's see what A9 is. On the bright side, I have been kissing up to my vice president, hoping I can get transferred to the IT dep. Hopefully it doesn't work out. I mean, it sounds like you really want to work in IT, dude, so I mean, I hope it doesn't work out for you, right? So you get put into IT. A9, anyway, so A9, so we had LDA, that was that one. Let's put this on top here. So this is this, and then we have 8.5, which is store into the accumulator, and then we have this one here, which is LDX, and then we have LDA again, A9, which we already support, by the way. And then after that we have LDA again. Ooh, I'm loving this. We already support this one too, right? Or do we? 85B0. Okay, so right, no, we didn't get that. So LDA was there. We have LDA, which is 8.5. Which one's LDX? A9. Wait, this is not right. Is this even working? I don't think this is the same code I got last time. So if you assemble it and run, oh, it is. It's the right code. So this is what the code does, by the way. That's what I'm trying to emulate. But did the binary get shifted or something? Let's see it again. So we have A9, which is this one here, A901, A5B1, A2FF, which is this one here. A2 is loading to XFF. And then we had loading to A again, 00. This one here, and then we have store into whatever is in the accumulator into memory B0, which we already support as well, and increment X. Oh, so increment B1, right? So we're going to increment whatever's in A, or increment the memory address B1, right? I did open my laptop now. I miss doing emulators. I tried doing it in not C++ this time around, probably Pascal will go. Stefan, have you tried it? Rust? Rust is actually a very fun language to write into, to be honest, and it might be worth writing something in there, because if you know C++, you'll be fine in Rust, as long as you're willing to learn some of the stuff. So increment B1, that's what we want to do. So let's look at that opcode and see if we can increment. So increment absolute value, we actually have the memory address one, right, which is 0 page. We have the 0 page here, which takes 2 bytes. So B0, B1 is the one we want. And is that what we have? So increment, the opcode is E6. So E6, B1, yeah, that's the one we have there. So this is what we have to do now. Increment 0 page. So it takes the memory and increments it by 1. And what does it say? The N and 0 flag. Okay, so this is kind of similar to what we had before, I guess. Right? Oh, Zelda. Not Zelda, not Zelda. Is it Zelda? I don't even know. I have tried it 7 times. I have the biggest skill issue with it, and I would rather avoid it nowadays, but because the failed experience with Rust, I ended up being better at C++. Are you better at C++ because C++ doesn't check your stuff as much? whereas Rust will not let you work with anything unless you do it right. So it's not really a skill issue, man. It's you know, just a practice issue. The more you practice, the more you learn. Like I started learning Rust, I think it was like a year ago, exactly a year ago, and I'm still basically a beginner in it. Granted, I know a lot more than I knew back in the day, and in fact, whenever I look at code that I wrote in Rust when I started working, I usually like ask myself, like, what the hell was I thinking? But the more I practice, well, the better I get at it. And yeah, you just gotta make sure that you're practicing all the time, man, because it's the same in every language, it's the same in everything in life, right? The more you practice, the better you get. Like, natural genius can only get you so far. The rest is practice. So that's what I tell people. And you know, this is a hot take, but I think unless you've done a language and you practice it every day for maybe a couple of years, you're still a beginner. You're still a beginner. Like I'm still a beginner in all of this stuff. So we have increment. So increment 0 page, right? That's what we have here. So increment 0 page, we don't need that bit there. We just need a program. Wait, how is this even working though? Because I don't... Oh yeah, we've got the CPU. We've got a CPU here. Yeah. We've got the PC counter. That's why it works. Increment 0 page. So that basically increments the memory by 1. So we need to... Well, there is no value in this case, right? I mean, there is the memory value, so the index or the position. And what we want to do is like we want to do a CPU.memory .position. Should we do some safety checks as well to make sure that, you know, that the position is actually, well, we know it's in the memory. It's a byte. So the memory is going to be plus plus. That's all we're going to do. And yes, I mean, we got to check that the CPU.mem in position is 0 or the CPU.mem position is a negative number. And we read 2 bytes. Yeah, that's it. Now we support another instruction. I have tried this 7 times. I'm aware I tried Rust across a wide array of projects, from web dev to microcontrollers. It just doesn't sit right for me in the same way that Ada or C++ do. No hate for it. Yeah, no, I understand that, yeah. I mean, to be honest, I find it intriguing. I like Rust. In the sense that, you know, it's very different to other stuff. But do I like writing in it? No, probably not. Like, do I want to... Would I rather do like a project in C++ or Golang? I've been getting to Golang quite a lot recently, or Rust. You know, I much rather prefer writing something in Golang actually than any of the other 2 languages that I mentioned. But C++ is my second best, so I'd go for that. It's just because like Rust forces you to do a lot of stuff that you don't necessarily need sometimes. Like sometimes it's okay to use unsafe code. And I feel like the subset or the set of like Rust correct programs that the compiler lets you compile is inside the set of actual correct programs that are still safe to run. And sometimes, you know, you may be able to do stuff in C++ that's completely safe, but you can't do that quite easily in Rust without having to invoke like unsafe code and stuff. So that's my main issue with it, to be honest, with Rust, to be honest. So I respect people who can handle Rust. Yeah. I mean, you can handle Rust too, though. I'm sure you can just practice a little bit more. I never did Ada programming, though. We Ada programmers like Rust because we finally have serious competition. What we could have been if we had more modern syntax and a solid open source community. That's true, yeah. yeah, I mean the Rust community is quite big actually. It's quite impressive. Like people are really crazy about it, and there is a crate, an open source project for it, and you know, for everything you can think of. Like someone's already made it before, and people love to rewrite things in Rust. They absolutely love to rewrite things in Rust. So I'll be impressed if like everything that's available in C++ right now isn't also available in Rust in the next few years. I mean, there's still a lot, by the way, but the community is going strong. So we increment the PC counter by 1. Increment the PC counter by 1 and then set the flags, which is carry flag. Is it carry flag? Wait, which flag is it again? That's setting. We set the 0 flag and the negative flag, right? So if it's 0, we set the flag 0, and if it's negative, we set that. But good. Which opcode was it again? I'm losing my mind now. E6. E6 is the one we have to add here. So E6 is definitely going to be... I mean, all these numbers are less than A or whatever. And then we have case 0x E6 here. We have increment 0 page, and we have the CPU and the program, and that is it. That's all I need, right? Then we break. But having it in the compiler is nice once you learn to love it. Yeah, indeed. Oh, I didn't read the message before that. I believe that you can do perfectly safe C++ if you keep the same borrowing rules in your mind and avoid rot pointers at all times. People underestimate modern C++ safety too much. Yeah, I mean, modern C++ is a lot better than like writing old school C++ with kind of pointers everywhere and raw memory copies and whatnot. But it's still like, you can still write some messed up bugs in it. You know, it's a problem when even the best like companies who have supposedly the best programmers in the world, you know, people like Google, Microsoft, and you can be sure that they're writing modern C++, then you know it's kind of like a problem. And yeah, I mean, but you know, in the same way, you can still write buggy Rust code. It only at most kind of prevents you from writing memory bugs, but there's other types of bugs that you can you can worry about. It doesn't like find for you at compile time. But yeah, I mean, you know, I find myself writing less bugs in Rust than C++ for sure, 100%. Yeah, so let's compile this, shall we? So increment 0 page. Now, what is my debugging file saying here? What I want to do is actually do the pixel drawing one. Okay, we are still running the stuff here, but where's the actual emulator? That's what I wonder. Yeah, let's put a breakpoint here, shall we? So we put a breakpoint on executing the next command, and let's go for it. So right, so we are gonna get the command, which is 169. I guess this is the LDA immediate, and we read how many bytes? 2 bytes, right? Return the bytes, and we increment the PC counter based on that. And then what do we have here? So we have command, we read the command now, which is 133. What's 133? In decimal. Oh, 133. 85, right? So we are expecting this to run an STA0 page, and then the value, what is the value? 177. Is it still doing my values correctly? 177, which is B1. And I can see B1 in here. So it seems to be correct, right? And that is good and well. Sorry, I am going to be chatting to you in a second. So we didn't, right, there was some issues here now. So on the third instruction, why does your title say SDL2 if you're using Raylib? There is something missing. Yeah, there is something missing. We started with SDL2 and we spent like an hour trying to get the Conan stuff to build. Which was fun. I mean, I fixed the Conan recipe for the package manager Conan, but then one of the viewers said that we can probably just use Raylib instead, and it's a lot easier. And I switched to Raylib, so I'm gonna definitely change the title. Thank you for mentioning that. With Raylib, there you go. There you go. And then there's a typo there too. Thank you, dude. Cool. Yeah, I mean, we still have an issue running the third instruction. So let's look at that one. 1, 2. So which one is this one? The command is 169. So 169 A9, right? So that's contain values too. Okay. So we do increment that by 2. And what is the one? This one. So this is 133. Oh, it's 85 again, so that should be fine, right? I don't think there's any bugs on this one. But the next one there will be. Wait, what? What is my program? Because there's a 0 here, that's why. Wait, what? I don't understand why it's not reading all of it. So the PC counter is at what? Register PC counter is at 4 now. Add to watch here. PC counter is 8, and then PC counter is 10, and then 12, and then 14, and they're not available anymore. What the hell? I can't just have a 14 size program, right? That's way more than that. Yeah, why does it stop here at 14? Which is 13A. Let's try that. Oh, okay, because it returns that. That's fine. Yeah, it's because we have an instruction that we don't yet support. And which instruction is that? 13A. Let's see which one is 13A. Right, which position is it in the program? What am I doing? What am I doing? So where's my breakpoint? It's here. The command itself is 13A. So what is that? That is 8A. And 8A is this one here, so which comes after A0. Now A0 is load into X or load into Y, right? A0 is load into Y, so it's whatever comes after load into Y here. Oh, TXA, transfer X to A, I guess, right? Let's see if that makes sense. TXA. Transfer index X to A and opcode is 8A, yeah. I mean, this is actually very easy now. So, what is this 8? What is the command again? A. Now, which flags does this set? Because we have to make the checks for that. So again, 0 and sorry, not 0. Bytes red, and we're probably gonna have a function called, I don't know, TXA in this case. It doesn't take anything, does it? Yeah, it takes 1 byte. Okay. So TXA is going to be there, and then we break. Let's create that. Increment 0 page is what I'm going to copy. TXA here. And we just need the program. And we don't need this anymore. In fact, we don't even need a program here at all. We're going to return 1 if you read it. Nothing could go wrong in this case. I think we don't need the position anymore. What we are going to do is we're going to do cpu.reg.transfer x to A, right? So A is going to be cpu.reg.x in this case. And we're going to check the register A. In this case, reg.a. It's just a value transfer in this case. For those who are interested, TXA just transfers the value from X register to A register. So it would be nice turning all of this into const explorer as well. Like certain functions, when they set a flag, you can check the result of the output against a particular condition, and this can be done. I guess we can add this with a macro or something. I don't know, so we don't have to write it out all the time, but we can think about that later. TXA, and then we have the CPU here. Okay, so we're gonna fail there. And this becomes very easy now because I didn't realize it, but we have a very easy way to find out which instructions we don't support by simply just looking at this. So yeah, whenever we hit the no pointer, check. There you go. So which command is this? This command is 13A. So what is 13A? 13A is 8A. It should have been here though. I just didn't compile it correctly. Let's do it again. Okay, let's run it even again. Like, which command is it? 145. So 145 is 91. So 91. So 91B0. What are we doing after TXA? After TXA, oh, okay. So start this is a 0 page indexed. So basically what we want to do here is get the value yeah, I mean, this is a difficult one because this is storing whatever is in the accumulator to the memory address that's obtained by reading whatever memory is on this and adding the registry X to it, right? So it should be similar enough to the accumulator. So STA 0 page, right? So it's going to be somewhat similar to STA 0 page. I do wonder if STA had memory checks. I don't see any pointer check. Sorry, any flags checks here. So STA immediate, and we don't set any flags. Okay, yeah, we don't set any flags. We just set it. So the one we want is this one here, 0 page and Y. Absolutely, a 0 page. There you go, indirect plus Y, that's the one. So this is 91, is that correct? Yeah, 91. It takes 6 cycles though. Ooh. Yeah, I'm thinking of how I'm gonna do this. Yeah, I mean, this doesn't set any flags, so it's fairly easy actually to implement it. So we want, I guess, the program here in this case, right? So std spam or std uintake t program. We do kind of want to check for another value. Where do we get the value? No. There you go. So this is going to return me a size t optional, and I have my value, which is at the register position PC plus 1. So it's actually very easy now. So this is the memory address. Okay, so the actual position is, you know, the auto const. This is the index, so in direction. The actual position is simply going to be cpu.mem at position, right? Ooh, no, index, my bad. And then this is what we're going to do. So this is position. At position, close CPU dot register.y here. There you go. This is what we wanted to do. This does need to check. I mean, just for safety. I mean, if something goes wrong, we can probably return no locked. If this index here isn't valid, by the way. Yeah, we should probably just do a check at some point. Good night, Matt. I'm leaving for now. Good luck with the emulator, and I hope to catch up next stream. Yeah, thank you, Stefan, for joining. And it's been really fun, dude. So yeah, have a good night, and I'll see you next time. Okay, I think that's right. Good night to you, Matt. I guess I'll have to watch the rest later. Yeah, thank you, Peter. Good night, dude. And yeah, I'll see you next time. I think I might call the stream here, to be honest. It's 11:30, but it's been fun, my man. So I'll see you next time, and bye-bye. I'm also quite tired.